Chapter 1, Section 9, Patterns, Equations, and Graphs. A solution of an equation with two variables, x and y, is any ordered pair. An ordered pair is in parentheses. You have your x value, comma, your y value. That makes the equation true. The first example says, is 515 a solution to the equation y equals 3x? Notice they've given me an ordered pair, 515, which tells me that 5 is the x value and 15 is the y value. What I need to do to see if this is the solution to the equation is plug in 5 for x and 15 for y. When I do that, I have 15 equals 3 times 5. Notice there's nothing to solve. There is something to solve here, but there's no variable. I'm not trying to get a variable by itself right now. All I'm trying to do is see if the two sides of the equal sign are in fact equal. So what I need to do to see if they are equal is multiply 3 times 5. When you multiply 3 times 5, you do get 15. So 15 equals 15 is a true statement. Because 15 does equal 15, and that is true, I can say that 515 is a solution to the equation. The next example says to determine if 2, negative 2, the ordered pair, is a solution to the equation y equals 5x minus 8. Again, they've given me my ordered pair, so I know the x value that I need to plug in for x is a positive 2, and I need to plug in a negative 2 for y. I'm going to use the equation y equals 5x minus 8 that they gave me, and I'm just going to substitute in 2 for x and negative 2 for y. When I do that, it says negative 2 equals 5 times 2 minus 8. The negative 2 is all by itself. I don't have to do, there's no operations with it, so negative 2 is going to stay on the left side of my equation. On the right side of my equation, I need to use the order of operations, so I need to multiply first. 5 times 2 is 10, and I still need to subtract 8. Notice my negative 2 has just come down. Negative 2 equals 10 minus 8. Well, 10 minus 8 is positive 2. So negative 2 does not equal a positive 2. So negative 2, the ordered pair, is not a solution to the equation. Notice in the last example that we had done, we got to, my last step said 15 equals 15. Because that was true, my ordered pair was a solution. In this case, I have negative 2 equals positive 2. That is not true. That's not a true statement. So it is not a solution. There are different ways to show a relationship between two different variables. You could create a table to show the corresponding x and y values. You could write an equation. We've worked on writing an equation with one variable, but now it would be writing an equation for two variables or two unknowns. Or you can draw a graph. If you are going to draw a graph, you have to make sure that you are labeling the axes that you are using. And we'll do an example here in just a moment of that. The example says Will runs 6 laps before Megan joins him. Then they run together at the same pace. Represent the relationship between the number of laps Will runs to the number of laps Megan runs using a table, equation, and graph. The first thing I want to create is a table. To show this relationship in a table, I need to have Megan's number of laps and Will's number of laps. I'm going to put Megan's laps on top and then Will's laps on the bottom because I know that however many laps that Megan has run, Will has run 6 more. So if you tell me how many laps Megan has run, it's going to be really fast and easy to find how many laps Will has run. So let's start with Megan running 0 laps. When Megan runs 0 laps, that means that she has not started running yet. And remember, it says that Will has run 6 laps before she joins him. So let's start with Megan, and I'm just going to start with 0, and then I'm just going to do 1, 2, 3, and 4. You could choose several different values here. That's just the easiest one, and it makes sense for this problem. They're probably not going to go run 37 laps, so we're going to keep the numbers pretty low here. If Megan has run 0 laps, we know that Will has run 6 because he has run 6 laps before Megan joins him. Now, if Megan has run 1 lap, we know Will has run 6 more than that, so 1 plus 6 is 7. For 2, we would do 2 plus 6 and get 8. For 3, we would do 3 plus 6 and get 9. And for 4, Will would have run 10, or 6 more than Megan. Using this table, first of all, take a moment to notice how the values are increasing or decreasing. You notice that Megan's laps are increasing by 1 each time, and that is the same for Will's laps. Will's laps are also increasing by 1 each time. The difference between them is that Megan's laps have started at 1, and Will's laps are starting at 6 when Megan's laps were 0. Megan's laps starting at 0. Now, we're also asked to use represent this relationship by writing an equation. When you're writing an equation, we're going to start using x's and y's. Now, you could technically use an m and a w, but because they also ask me to graph, I'm going to go ahead and start using x's and y's because my ordered pairs are in x's and y's, and just get used to using those variables. When we are writing an equation, we need to define our variables or tell what the variable represents. So in this case, my x value are going to be the number of laps Megan has run. That was my starting place, so I'm going to start with let Megan's laps be x, and I'm going to let Will's laps be y. When I write an equation, again, it's generally y equals, and then you're performing some operation on x. So I'm going to say that y equals, or Will's laps equal x plus 6. So what that says is that Will's laps equal the number of laps Megan has run plus 6. The last thing that we were asked to do is to create a graph. So I'm going to use the table that I had already created on the previous slide to create my graph. And I'm going to do that by plotting the points of Megan's to Will's laps. So I'm going to start by, first off, having a graph. Notice I've labeled my axes. The x-axis, or the one that is horizontal across the bottom, I've labeled as Megan's laps. And the vertical axis, or the y-axis, I've labeled as Will's laps. You also need to make sure that you label your graph or give a title to your graph. So Megan's and Will's laps will work again. Now I'm just going to plot these points. On the x-axis, when Megan's laps were 0, so I'm going to be starting at 0, Will's laps were 6. So I need to stay at 0 on the x-axis and go up to 6 on the y-axis and plot a point there. When Megan's laps were 1, so on the horizontal line I'm going to go to 1, Will's laps were 7. Notice my numbers on Will's laps, the y-axis are going up by 2. So I have 0, 2, 4, 6, 8. So 7 isn't actually on one of the lines. It's right in between 6 and 8. For Megan's laps being 2, Will's laps were 8. For Megan's laps 3, Will's laps were 9. And for 4 laps for Megan, Will's laps were 10. And I've just used the points that I had found in the table to plot these points on a graph. If you notice, I could take these points and draw a straight line through them. So we can start looking at relationships and tell if they are linear or not. We know that this would be a linear relationship because all of the points that I'm plotting are in this straight line, and I could draw a straight line and it would hit all of the points that I have drawn. The last example says the table shows the relationship between the number of chairs and the total number of legs. Extend the pattern. What is the total number of legs on 10 chairs? If you notice, X would be the number of chairs and Y would be the number of of legs. So when you have one chair, you have 4 legs, which if you think about it, that would make sense. When you have 2 chairs, you have 8 legs. 3 chairs, 12 legs. 4 chairs, 16 legs. And 5 chairs, 20 legs. If you look at the X values and the Y values, for example, look at 1 and 4. What can you do to 1 to get 4? What can you do to 2 to get 8? And you're trying to find the same thing that you can do to all of your X values to get the correct corresponding Y value. So the pattern shown in the table is that you can take the X value and multiply the number of chairs X by 4 to find Y, the number of legs. So if we wanted to find the number of legs on 10 chairs, we could multiply 10 times 4 and find that on 10 chairs you would have 40 legs total. Today's assignment is on page 72, numbers 2 through 34 even.